Howdy, howdy, howdy. This is going to be electron configurations, but we're only going to talk about the rules of electron configurations. How to do electron configurations will be in a separate video. Electron configurations describes the ways in which electrons are arranged around the nuclei of atoms. The first 18 elements here are listed all the way up to argon, which is number 18, starting with hydrogen, the first one. And here are the electron configurations. And what you'll notice is that each one is unique. They all have a different electron configuration. So I like to call this, just like you as a student have an ID, this is the identification barcode of electrons and elements. So we have three rules that we're going to cover that govern how we fill in atomic orbitals. In the next video, we're going to talk about orbital diagrams. So the first rule is called the Aufbau principle, and this states that electrons must enter orbitals of lowest energy first. Lowest energy. So we're talking about the principal quantum number n, right? Where we have 1, 2, 3, 4, 5, 6, 7, which would be the last row of the periodic table. So we have to fill in electrons first, starting with s, and then we can go to the second energy level, and then we can go to the third and fourth and fifth and so on. We cannot fill in electrons of higher energy before we go back and fill in the lower ones first. That is the Aufbau principle. Rule number 2, Pauli exclusion principle. An atomic orbital can contain at most 2 electrons. They must have opposite spins. So when we cover orbital diagrams, which we will in the next video, you're going to see things that have 1s, which would be the first energy level in a spherical shape, and you're going to see a little bubble or a line. This represents an atomic orbital, and you'll see 2s, and it has an orbital. Well, it can contain 2 electrons in here, and they must have opposite spins. That's why I'm drawing an up arrow and a down arrow. Usually the spins have a charge of plus 1/2 and minus 1/2. So on 2s, now we can go and use Aufbau principle. We can go up to the second energy level. Aufbau says then we can fill in 2 more, and we have to follow the Pauli exclusion principle, where we have to have 2 in each. Now, when you get to 2p, you will see 3 orbitals. And after we filled in 2s, we can move up to 2p. And we're going to learn about our next rule and how we fill these guys in. But remember, overall, we can only have 2 in each, and each has to have 2 opposite spins. The last rule of this video is Hunds rule. When electrons occupy orbitals of equal energy, 1 electron enters each one first until all of them contain 1, and then we can go back in and fill in the second one. So here's the definitions. Let me fill in an example. So we have 1s, boom, boom, 2s, boom, boom. Now, 2p is when things get a little strange and we have to follow Hunds rule. He says that when you're filling in these guys, you can't just go in and fill in all the arrows at once. You have to give everybody an electron first. So my example to my students is when Halloween comes around, if I'm giving out candy to my classroom, I want to give every student a piece of candy before I go back and give someone a second piece. I wouldn't give someone 2 pieces until I make sure everyone has 1 piece of candy. So that's what I have to do here for Hunds rule. I fill in the first 3, and they have parallel spins. They're all up. Then I can go back in order and fill in the last 3. That is Hunds rule. And we're going to stop there today.